Namaste. Welcome to tutorial series on SuperPro Designer for Beginners, step-by-step guide to process simulation. In this video, let us understand how to solve a real-time example or simulate a real-time process using SuperPro Designer. For easy understanding, I have divided the series of actions what we perform in SuperPro Designer into several steps. So in this case, I have divided into 10 different steps. In the first step, we can notice that once we open a new process file, we need to select the mode of operation, that either we carry out the process in batch mode or continuous mode. Once we choose the operation, then we have to register the components which are involved in simulation of that particular case. So either the components may be available as a pure components, or some of the components or some of the ingredients what we use in the process simulation may be stock mixture. The best example I can tell you is air, which is used, one of the reactant in the bioprocess industry, is a stock mixture of multiple components like nitrogen, carbon dioxide, oxygen. But for simulation purpose, what we try to do is we limit ourselves and we assume that air is a mixture of nitrogen and oxygen. Once we register the pure components and stock mixture, the next step is we need to develop the process flow diagram or process flow sheet based on the information given in the problem statement. Once we develop the process flow sheet, then we need, as it is a batch process, we need to add series of operations which are involved in that particular process. Once we set up this process flow diagram, then we have to initialize the stream. That is what is getting fed into the system, at what rate it is feeding, what is the conditions that the feed is entering, for example some temperature, pressure, all these things we have to initialize in the stream initialization step. Next, once we initialize the stream, we move ahead and initialize the operations in the particular unit procedure. For example, you are using a batch reactor, so we need to charge the reactants, we need to heat the reactants, we need to allow that reactant mixture to undergo the reaction. Then once the reaction is completed, maybe we will transfer out. So it is not limited to 3 to 4 steps. Depending upon the problem statement, we might have multiple steps in each unit procedure. So once you initialize all the procedures, streams, everything, then we need to perform the material and energy balances. Once you perform material and energy balance, we can analyze the result. And next very important thing is we need to schedule the operation. Scheduling indicates that there are series of operations are available. So each operation needs to be operated at particular time. So that we need to schedule the operation. Then very important thing is we need to classify the stream, because when you want to calculate the revenue of the process, or when you want to calculate what is the environmental impact of the outputs available in this particular process, then definitely we need to classify the streams. Means which stream is a raw material which you are going to feed into the stream, which is the product stream that fetching you the revenue, and which is the stream which is the waste stream which is impacting the environment, that need to be treated before is releasing into the environment. To perform such actions, definitely we need to do the stream classification. Next very important step is economic analysis or cost analysis. To understand the overall economics of the process, we need to perform this action. But there are series of economic analysis, different ways of economic analysis are there, that we will look into it later once we finish the simulation. And last but not the least, the very important thing is we need to understand the impact of this particular process or environmental impact of this particular process. Means whatever pollutants which you are going to generate, or whatever the effluent you are releasing into the environment, that how it going to impact, we can easily visualize and understand our post simulation. And for understanding better, I have taken one case study, or I have taken an example problem, that is aspirin production and purification. So the problem statement is as follows. The production of aspirin involves the reaction of salicylic acid and acetic anhydride using phosphoric acid as a catalyst. So the reaction stoichiometry of aspirin synthesis is as follows. That is 1 mole of salicylic acid react with 1 mole of acetic anhydride, gives you 1 mole of aspirin and 1 mole of acetic acid. So as a pilot scale production, So there is like 100 liter of acetic anhydride is charged and 60 kg of salicylic acid is charged to the reactor along with 2 liter of 85% phosphoric acid into a batch reactor. From this statement we can understand, so we need to simulate a batch process. Next one, once the reaction, like once the ingredients are fed to the reactor, first thing is we need to heat the ingredients, all the reactants, to the temperature of 350 Kelvin using steam as an heating agent at the rate of 0.5 degree per minute. So once you have heated the reactants, you are allowing that particular reactants to undergo the reaction for 60 minutes at that isothermal condition, that is 350 Kelvin. And once the reaction is completed, so we are going to cool the reaction mixture to 20 degrees centigrade at the rate of 0.5 degree per minute using glycol as a cooling agent. And once the solution is cooled to 20 degrees centigrade, we need to add 25 liter of deionized water which is available at 15 degrees centigrade, and we need to hold the reaction mixture now for 30 minutes to allow to crystallize, allow aspirin to crystallize. Once it is done, so here one more assumption is done, one more assumption is there, that is we assume that salicylic acid is reactive in this acetic anhydride or acetic acid, and also aspirin is virtually insoluble in these two solvent, means aspirin is completely crystallized. Once this mixture, the crystallization is completed or held for 30 minutes, we need to transfer this mixture, whole mixture, into plate and frame filtration unit, and filtration is carried out for 1 hour, and which is operated at 98% removal efficiency of aspirin. So and also there is one more step in the filtration. Whatever the cake which is generated during the filtration process, that is further washed with 95% ethanol at a temperature which is available at 15 degree centigrade. And most of that setup time or process time and scheduling some of these operations, we go with the default values as per the process requirement. And it is expected us to calculate or estimate the reactor volume which is required to carry out this particular process. And next very important thing is we need to calculate the turnaround time for one batch of aspirin production, because this is very important, because if you can understand how much time is required to produce one batch of aspirin, so we can easily calculate how many batches you can calculate per year. So basically we need to understand the overall economics, and later as I told, we need to also understand the economics of the overall process. And also some other information is given, physical properties of salicylic acid and aspirin are given, so you can notice some of the important properties are given here. Let us see why do we need this particular physical properties. So in the next video, let us start solving this problem using SuperPro Designer. Thank you.